Hi, geometry. This is solving our quadratic equations by finding square roots of both sides. So let's think about the simple equation x squared equals 9. What things can x be? Well, I'm thinking in my head, and if I square a -3, I get 9. And if I square a +3, I also get 9. So x could be equal to a -3, or x could be equal to a +3. And when I square it, I would get a +9. Therefore, when I'm solving a quadratic equation, there will always be one positive and one negative square root. So how does this work? So when we solve square root equations, we're going to solve for x by taking the square root of both sides. The moment I take the square root, I have a positive and negative square root. In other words, x could be a positive or a -5. And when I square the -5, I get positive 25. When I square a +5, I also get a positive 25. So x could be a 5 or a -5. And you can write that either as a plus minus in front of 5, or you can write 5 and -5 separately. What about something that's not a perfect square root? So for example, if I take the square root of both sides, I have plus minus the square root of 24. So x equals plus minus the square root of 24. And on my calculator, if I take the square root of 24, I get 4.89. So that means that my x is either equal to the positive square root of 24, which is positive 4.89, or it's equal to the negative square root of 24, which is negative 4.89. So when I have a plus minus, it's the same as writing it as a plus answer and a negative answer. So to solve these, your step 1 is always to isolate the squared term. So I want to get the squared term by itself, and then my step 2 is going to take the square root of both sides. Sorry about that. Square root of both sides. So let's look at these examples on this page. Let me move this up. So first of all, in example 1, my x squared is not isolated. So I'm going to divide both sides by 4, and I get my x squared term isolated. I'm now going to take the square root of both sides. The moment I take the square root, I'm going to put a plus minus, really tiny, squeeze it in there. And I get that x equals plus or minus the square root of 9. Well, the square root of 9 is 3. So my x equals plus or minus 3. That's two answers. You can also write it as x equals 3 or -3. So number 2, in order to isolate this one, I have to add 15 to both sides first. And I get 3x squared equals 15. Sorry about that, 15. To divide both sides by 3. And I get x squared equals 5. I'm now going to take the square root of both sides. And I get x equals, and that's plus or minus the square root, x equals plus minus the square root of 5. And if I do the square root of 5 on my calculator, I get 2.24. So x equals a positive 2.24, and x equals a negative 2.24. Let's take a look at example 3. Example 3, I have to add 16 to both sides, and I get 9g squared equals 16. Now I have to divide both sides by 9. I get g squared equals, I could do 16 divided by 9 and write it in decimal form, but they're both perfect squares. I'm actually going to leave it as 16 over 9. And I'm going to take the square root of both sides. So it's plus minus my answer. So g equals plus minus, and the square root of my numerator, the square root of g equals, let me erase that plus minus where it is. G equals plus minus. The square root of my 16 is a 4 on top, and the square root of 9 is a 3 on the bottom. So one way to write this is the square root of is plus minus 4 over 3. Could you have done it as decimals? Sure. Let me grab my calculator. 16 divided by 9 is 1.7 repeating. So I would have had, for example, g squared equals 1.7 repeating. And then when I took the square root of both sides, I would have had g equals plus minus, and the square root of that would be 1.3 repeating. So you'll find that 4 divided by 3 is equal to 1.3 repeating. So you could have worked with decimals on that problem and been just fine. So let's take a look at number 4. I'm first going to subtract 6 from both sides, and I get 3x squared equals 27. I'm going to divide both sides by 3, and I get x squared equals 9. So now I'm going to take the square root of both sides. When I do that, I get x equals plus or minus the square root of 3. And that brings me to number 5. So on number 5, to isolate the square term, I'm first going to subtract 6 from both sides because it's a positive 6. So to move it, I need to subtract 6. And I get negative 1/3 x squared equals negative 26. Now, I have negative 1/3 times x squared, and if you remember when we work with fractions, to cancel them I multiply by the reciprocal. So first of all, the reciprocal is to multiply both sides by a negative 3. So when I multiply by the negative, my negatives are going to cancel on the left side, and when I multiply by 3, my 3 and my 1/3 are going to cancel. So let me also multiply this side by negative 3 over 1. So my negatives cancel, my 3's cancel, and I just get an x squared on my left. That's what I wanted. I wanted to isolate my x squared term. Now on the right side, I have negative 3 over 1 times negative 26 over 1. And negative 3 times the negative 26 is a positive 78. So now I'm going to take the square root of both sides, and I get x equals plus minus the square root of 78. And when I do the square root of 78 on my calculator, I get 8.83. So let's take a look at number 6. First of all, I'm going to add 1.2 to both sides. When I do that, I get 0.1 x squared equal to 10.0, if you will. So I'm going to divide both sides by 0.1. And when I do that, I get x squared equals 100. And when I take the square root of both sides, put a plus minus in front of that square root, I get x equals plus minus the square root of 10. So, thank you, and bring any questions you have to class.